In this lesson, we'll be looking at the different things we know about the angles of polygons. And remember, if you remember in our investigation at the beginning of this unit, we were looking at the relationship between sides and the angles of polygons. And now we want to kind of formalize some of that knowledge that we know and understand about the angles of polygons. And so there's a few theorems that we'll want to talk about. The first one is the polygon interior angles theorem. This is what we were investigating at the beginning of the unit. That's just saying that the sum of the measures of the interior angles of a convex n-gon, so that just means any polygon, is 180 degrees times n minus 2. So if we take the number of sides of a polygon, subtract 2, and then times by 180, that would be the sum of the interior angles. Okay? All of the angles of that polygon added up together. So we just need to know the sides and then complete the formula. So like this would be an example of where we're determining what is the sum of the measures of the interior angles of a certain figure. So this octagon, which has 8 sides, if we want to determine the sum of all of the angles within that octagon, we would just take 8 minus 2, which is 6, times 180, 1080 degrees. And so that would be the sum of all of the angles within that figure. And so that's a very simple formula that you just need to be able to work with. Take the sides, minus 2 times 180. We can also determine what figure we have using this same formula. So if we're given the sum, and this, instead of finding the sum of all the angles, we're given the sum of all the angles, we can then classify the polygon by its number of sides. So in this example, which is also in your notes, we're given that a particular polygon has the sum of all of its angles is 900 degrees. Okay? The sum of all of its angles is 900 degrees, and so we want to classify that by a number of sides. So we can set up our formula just like before, but instead of plugging in for n, in this case we don't know the number of sides, but we do know the sum, and so we're going to set it equal to 900 degrees. So 180 degrees times n minus 2 equals 900 degrees. So I'll divide by 180 on both sides, and then I'm left 900 divided by 180 is 5, and then I'll add 2 to the other side, and I get 7. And so what we find there is that when a polygon has 900 degrees, we get has a sum of interior angles is 900 degrees, we get that n is equal to 7. So that's the number of sides that polygon would have, which makes it a heptagon. Okay? And so that's kind of the reverse of that. If I have the sum and I want to figure out the number of sides. Another theorem is just a corollary, so just kind of a side or supporting theorem to the polygon interior angles theorem. Says that the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So that's just saying that every quadrilateral, the sum of all of its angles is 360 degrees, which is something we investigated at the beginning of the unit as well. So if I know that every quadrilateral, all the angles add up, interior angles add up to 180 degrees, then I can look at this figure here. I have a missing angle, and so I add up all of those together. Ax plus 108 plus 121 plus 59 equals 360, because that's the sum of all of them. Set up that equation, and then solve for x. I get x is equal to 72. So again, understanding that all of those angles would add up to 360 because it's a quadrilateral with 4 sides, I can set up that equation and solve for x. The last theorem in this lesson is the polygon exterior angles theorem. So far we've just been talking about the interior angles, but the exterior angles of a polygon, we can also understand something about them. The sum of all of the exterior angles of a polygon, a convex polygon, with one angle at each vertex is 360 degrees. So that's every convex polygon. All of the exterior angles of that polygon are going to add to 360. So like in this figure here, you see we have these exterior angles. We're just kind of extending each of the sides out, and then the exterior angle is what's made with the side and the extended angle, or the extended ray off of the other side. And so we have these 4 exterior angles here. And the theorem says that they should all add up to 360. So if I want to determine what x is, I would just add them all up, equal 360, and solve for x. Okay, so identifying that, okay, these are exterior angles, all of them together, and so they're all going to add up to 360. Lastly, a regular polygon. So far we're just talking about general polygons, which is based off of their sides. But a regular polygon is specifically both equilateral and equal angular, meaning that all of the sides are congruent. Okay, all of the sides have the same measurements, and all of the angles are congruent. They all have the same measurement as well. So if a polygon is like that, where it has all of the sides equal and all of the angles equal, we say that's a regular polygon. And so we're actually going to look at an example where we use the fact that the figure we're given is a regular polygon to determine something about the angles. So let's look at that example now. It says a trampoline is shown shaped like a regular dodecagon. And so in this example, we'll be using the fact that we have a regular polygon, which is both equal angular and equilateral, to determine something about the angle measurements. So we have this regular dodecagon. Okay? And a dodecagon, if you didn't know, has 12 sides. You could also count the trampoline, but a dodecagon is going to have 12 sides. So using that fact and the theorems that we've learned in this lesson, we'll be able to find the measure of each interior angle and the measure of each exterior angle. So let's start with A there. A says find the measure of each interior angle. Well, we have a theorem that finds the measure of all of the angles, so let's go with that. So our theorem says that if we take 180 times the number of sides minus 2, that will give us the sum of all of the interior angles. And so I can do 180 times 12 minus 2 times 10. That's 1800 degrees. So 1800 degrees is the sum of all of the angles in that dodecagon. But this question in A is specifically asking me to find the measure of each interior angle. Okay? So just one of the interior angles. But the thing is, each interior angle of a regular dodecagon should all be the same. So if I find one, I find all of them. And because they're all the exact same, and there's 12 sides, and so there's 12 vertices, okay, and so that means 12 angles, we can just take the sum of our total measurement, okay, 1800, and divide it by the number of sides. Okay? So 1800 degrees divided by 12 is equal to 150 degrees. And so that's going to be the sum, or that's going to be the measure of each interior angle. And we can only do that because it's a regular dodecagon. If it wasn't a regular polygon, like a regular dodecagon, we couldn't just take it divided by the number of sides because some of the angles could be different. But because we know they're all the same, we can take the total sum divided by how many sides there are, which is how many angles there are. So that's finding the measure of each interior angle. Next on B, we're finding the measure of each exterior angle. Well, we learned in our exterior angle theorem says that the exterior angles of any polygon are going to be 360 degrees. So the measure of all the exterior angles, okay, if I extended each of these sides out, all of the exterior angles would be 360 degrees. And again, because it's a regular polygon, or a regular dodecagon in this case, all of the exterior angles should be the same. So if I just take the total measurement of all the exterior angles, 360, divided by the number of angles, 12, that will give me each angle. So in this case, 30 degrees. So each interior angle is 150 degrees of this dodecagon, and each exterior angle of this dodecagon is going to be 30 degrees. And so I just use my formulas and the number of sides to determine that. But an important piece there was to recognize that because this is a regular figure, all of the angles, exterior and interior, would be the same.